Okay, we start off with two triangles, and ignore the markings. Just look at the dimensions of the triangles, and tell me, is it possible that this triangle is just a blown up version of this triangle? Okay, yeah, you should answer that on your own without looking at anything, but yeah, we got a pretty immediate response from a couple of students who said, well, yeah, every side of this triangle is twice the side of this triangle, so we have a ratio of 2 to 1 between this side and this side. 40 is twice 20, so 40 over 20 is 2. 24 over 12 is 2. 42 over 21 is 2. So the sides are, the corresponding sides of this triangle is always double the corresponding side of this triangle. So we can say the second triangle has sides that double those of the first. 40 over 20 is 2, 24 over 21, 42 over 21, all 2. That means that the triangles are geometrically similar. This is a scaled up version of this, and all the angles are the same. All the corresponding angles are the same. So the angle between the 40 and the 42 is the same as the angle formed by the 20 and the 21. That is, angle D is equal to angle A. The angle formed by the 12 and the 20 here is the same as the angle formed by a 24 and the 40 here, and similarly for this third angle. Okay, so now we're going to say that angle A corresponds to angle D because, again, the side 40 corresponds to the side 20, side 24 corresponds to side 12, the side 42 corresponds to side 21, because those are the sides that give us these ratios: corresponding sides, corresponding sides, corresponding sides. And we mark the correspondence with one tick mark for these two sides, one tick mark, two tick marks for these two corresponding sides, three tick marks for these corresponding sides. So again, angle A corresponds to angle D because angle A is formed by two sides that correspond to the two sides that form angle D. And similarly with angle B and C, angle C and angle F. So this whole idea of similarity, of one triangle being a blown up version of the other, the triangle is similar if the corresponding sides are all in the same ratio. The second condition, we can say that therefore corresponding angles are all equal. And then we can say, if we have these two conditions, that condition 1 implies condition 2 and condition 2 implies condition 1. That means that if the triangles have corresponding sides all the same ratio, then the angles are all equal. And conversely, if all the angles are equal, then the corresponding sides have to all be in the same ratio. So either of these conditions alone implies similarity, and similarity implies both conditions. So again, condition 1 would imply similarity. That means if condition 1 holds, then the triangles have to be similar. Similarity implies both conditions. What's this mean? It means that if the triangles are similar, then you have both conditions. And also condition 1 implies condition 2. If condition 1 holds, then condition 2 has to hold. And if condition 2 has to hold, then condition 1 has to hold. So that's the idea of similarity. Okay, now here's a figure. And these yellow markings weren't there originally. There's no assumption that this angle is equal to this angle. But if you have this figure, what condition on angles or sides or whatever would make this triangle here congruent to this triangle here? In other words, is triangle EAC similar to triangle DBC? Okay, the small triangle, the big triangle. So there's a question mark. And the question is, under what conditions would this triangle be similar to this triangle? And I'm going to write down just a little bit of that. And don't look at what I've written in yellow, but think, just draw this figure. Now, I will say I've seen somebody sitting with an iPad and this picture and multiple choice questions asking to determine what condition. It gives 4 conditions on this figure, and which of those 4 conditions would make these 2 triangles similar. That's not a bad exercise, but I have some real reservations about people picking solutions out of a set of multiple choice solutions unless they're also constructing solutions. Okay, I think you need to be able to draw this picture and make annotations in the picture rather than sitting and passively looking at a bunch of possible choices. Although there is some value to the multiple choice, especially if it's a well-designed multiple choice, it cannot replace drawing the figure and playing around with it. I would much prefer a question here that asks what we've asked here. What conditions might make these 2 triangles similar? We're going to see one condition in a minute. Now I'm going to go off screen for a minute and write something in here, but think of what conditions could make this. What are some of the conditions that would make these 2 triangles similar? Okay, hopefully you paused and done that. All I've written here is the question, what conditions would make it so, would make these 2 triangles similar? Okay, well, I'll give you one example. One example is they're similar if EA is parallel to DB. Now, they might look like they're parallel, but we have to state that. If we actually measure all these things, we'll find that they aren't. You can't possibly draw a picture where you do have absolute parallel. In any case, it's not stated that these are parallel. There's nothing in the statement of the problem that would allow you to assume they're parallel. But if we're writing a condition under which these 2 triangles would be similar, then these 2 lines being parallel would do it. Okay, now why is that? It looks like it ought to be true, but does that really prove anything? Well, if these 2 are similar, then here we have a transversal of, if these 2 lines are parallel, then we have a transversal of 2 parallel lines. And we have corresponding angles that have to be equal. Now, if these angles are equal, then the smaller triangle has angle at C, angle C equals and this angle, and the bigger triangle has angle C and this angle, which is equal to this angle, meaning that we have 2 angles, this angle and this angle in the small triangle, this angle and this angle in the large triangle, and they're both equal. Well, if the corresponding angles are all equal, then the triangle is congruent. If 2 of the angles are equal, then the third angle has to be equal, because the angles have to add up to 180 degrees. So these 2 angles add up to something. Subtract that from 180 degrees, you get this angle. And these 2 angles add up to the same thing. So when you subtract from 180 degrees, you get this angle, and you get the same thing you would have gotten for this angle. So that is sufficient to prove similarity. And we've actually used a condition I haven't written down here, but you'll see in your book that if 2 angles of the 2 corresponding angles of your triangles are equal, then the triangles have to be similar. Now, also, if these 2 angles are parallel, you could easily conclude that this angle equals this angle. So these angles are equal and these angles are equal if these 2 lines are parallel. That's one set of conditions on this figure that would make the 2 triangles similar. You should try to think of others. There are several conditions that would make them the same. Now, of course, if you just state the condition that this angle is equal to this angle, then that is sufficient to prove similarity. And incidentally would prove that these 2 lines are parallel. If you assume this angle is equal to this angle, you can make similar conclusions, and you get the result that the 2 triangles are indeed similar.